Okay, this video is about polynomials and the different characteristics that they have. So for this video, or this first section, we're going to look just at this polynomial that I have at the top. And first, we're going to talk about standard form of a polynomial. And standard form as a polynomial is when you write all the terms in descending order. Okay, so what does that mean? That means you're going to go from the biggest degree to the smallest. So you're looking at the exponents. And so sorry about that. The highest exponent in this one is x to the fourth. So that's going to go first. And because there's a positive in it, I'm going to keep it positive. Okay, and then next I would have minus 9x to the third. I'm using the sign that's in front of it. And then I have negative 2x squared plus 3x minus 7. So that would be that polynomial in standard form with the highest exponent first. The degree of the polynomial is the highest exponent. So on this one, the highest exponent is 4. So 4 is the degree of the polynomial. The number of terms are separated by plus and minus signs. So on this one, it's got 1, 2, 3, 4, 5 terms. Now, the one thing on here that I realized I had forgotten was the leading coefficient. And the leading coefficient is, in standard form, the number in the first term. Okay. Now, terms are separated by plus and minus signs. So if we look at this polynomial in this example, the first term is x to the fourth. Well, the leading coefficient is the number in front of it. There's no number in front of it. So when there's no number, there's an invisible 1. So for this polynomial, there's an invisible 1. Okay, now we're going to look at these graphs for a second because there's something else about polynomials that we're going to describe, and then we're going to put this all together. We need to look at the ending behavior. So we've seen this first graph. This is x squared. And if we're looking at the ending behavior, it goes up to the left to infinity and up to the right to infinity. And if I were to describe that, I'm going to use 2 upward arrows. It's both going to go in the same direction. But if I look at this one, they're both going down. So I'm going to describe it with this pattern. Finally, I have the cubic. Well, in the cubic, to the right, it's going up, but to the left, it's going down. It's different. They're not going the same direction. Well, we can figure out a few things when we look at this. Like we know x squared is always going to go up, but because this one has a negative, we know it's going to go down. Okay, so the negative is forcing it to go down. The positive out front is forcing it to go up. But what makes these two, the graphs 1 and 2, both go the same direction, and the third graph go opposite direction? Well, it has to deal with their degree. These have a degree of 2, which is an even number, so they're going the same way. But this has a degree of 3, so it's an odd number, so it's going opposite ways. So we can put this little chart together to help us remember it. If it's got an even degree, it's going to always be going the same way. So same direction. And if the leading coefficient is positive, that same direction is up. But if that leading coefficient is negative, like this one, that same direction is going to be going down. Odd degrees go different directions. Okay, they split. And if you think of a line that has positive slope goes up to the right and down to the left. Well, that's what this one does, up to the right and down to the left. But if a line over here has negative slope, it's down to the right and up to the left. And so that's what our pattern is. Now, your notes, if you print them off from the computer, are going to be slightly out of order because the formatting had to change. So we're going to flip to this page right here. Okay, so what we're going to practice is we're going to take a polynomial, put it in standard form, and then identify the different things on here. So on the first one, in standard form, the first one would be 9x to the fifth, because that's the highest degree. And then we have a third, so 2x to the third, then minus 8 squared, and then minus 4x. The leading coefficient is the number for the beginning of the first term, which would be 9. The degree of the polynomial is the highest exponent, which would be 5. The number of terms, 1, 2, 3, 4, 4 terms. Now for the end behavior. Well, we're going to look at the degree. The degree is odd. So odd means they're going different directions. Because the leading coefficient is positive, think of a positive slope of a line. It's going up to the right. So it's going to be up to the right and down to the left. Let's try the next one. We have, the first one would be negative 12x to the sixth minus 2x to the fourth minus 3x cubed plus 8x plus 11. So the leading coefficient is the number in front, which would be negative 12. The degree of the polynomial would be the highest exponent, which would be 6. The number of terms would be 1, 2, 3, 4, 5. The end behavior. Okay, well, this time the degree is 6, which is a positive, or which is an even number. Even means they're going to go the same direction. But since the leading coefficient is negative, that same direction is going to be down. All right, let's rewrite the next one. So I'm going to have 4x to the 4 minus 7x squared plus 6x. So the leading coefficient is the number in front, which would be 4. The degree is the highest exponent, which is also 4. The terms would be 1, 2, 3 terms. Now for the end behavior. Because the degree is even, it's going to be going the same way. And because it's positive, that same way is going to be up. All right, let's look at the next one. So the highest one would be what? Negative 11x to the 7th plus 6x to the 4th plus x to the 3rd minus 2x squared minus 7x plus 18. Okay, we got a long one. The leading coefficient is the number out front, should be negative 11. The degree is the highest exponent, which is 7. The number of terms would be 1, 2, 3, 4, 5, 6. Now we have to figure out the end behavior. The degree is odd, which means it's going different directions. Okay. The leading coefficient is negative, so it's going to have a negative slope. And if you have a line with a negative slope, it's going down to the right. So we have down to the right and up to the left. Let's do 2 more, and then we'll go on to something else. On number 5, the highest one would be 9x to the 8th minus 5x cubed. The leading coefficient is the number out front, which is 9. The highest exponent is the degree, which is 8. There's 1, 2 terms. On this one, the degree is even, so they're going the same way. And because it's positive, that same way is going to be up. All right, one more. We have negative 7x to the 5th minus 12x to the 3rd plus 10x squared plus 8x minus 11. So the leading coefficient is the number out front, which is negative 7. The degree is the highest exponent, which is 5. The number of terms would be 1, 2, 3, 4, 5. And for the end behavior, well, if we look at this, the degree is odd, so they're going opposite directions, and it's negative. So it'd be like this one. It's got negative slope, and negative slope goes down to the right, so it's going to be up to the left. Okay, if we go back to the other page, the last thing that we have is sketching some of these graphs, and we can figure this out. So what basically is they're giving us some information to describe what the graph looks like, and then we need to graph it. So the first thing they give us is the negative and positive intervals. And we know negative intervals is everything that's below, and positive intervals is everything that's above the x-axis. Okay. And so if we had a line and it started below and crossed the x-axis and became positive, where it would cross would be right there on the x-axis. So therefore, it would be an x-intercept. So the negative and positive intervals give us our x-intercept. So you can look either at the negative or the positive. It's going to give us the same values, but we're going to look at the numbers. So the first number is -5. So my first intercept is going to be -5, 0. And then people freak out and say, oh, that's an ordered pair. Oh, no, no. This is not an ordered pair. This is intervals. This is interval notation. And in interval notation, we look only at the x values. So these are all x values, and we read them left to right. So from -infinity to -5, it's going to be below the x-axis. From -1 to 3, it's going to be above the x-axis. Okay? Oh, excuse me. I did that wrong. Here's negative. And then here's going to be negative. There's a section positive over here. And I can't draw circles in the right spot. And there's another section positive over here. So we're trying to figure this out. Okay, so now let's look at the other one. We've got -1, 0. And then we have 3, 0. If I had used positive, I'd have -5, -1, and 3. Same numbers. You do not use the infinity because you can't plot infinity. So the next thing we need to do is plot these points. Okay. So I plotted those 3 points. Now increasing and decreasing. Remember, if it's increasing, it's going up. This is increasing. And if it's decreasing, it's going down. So when these intervals are here, that means that at this point, it stops increasing at -3.5 and then starts going down. Okay, so these are what I like to call turning points, because at these points, the graph is going to turn direction. Now, it's not an actual point, it's a line. So that's a little deceiving calling them points, but it's the same idea. So we've got -3.5, 1.25, and the rest are infinities. We don't do that. If I had used the decreasing, you'd have the same numbers. So what I'm going to do is I'm going to draw a line at -3.5, which would be right here. And I'm going to draw a line at 1.25, which would be right here. Okay, so then it says we got to now figure out where our graph is. And it's just going to be a sketch. So it's not going to be exact, but it's going to give you the flow of how it goes. Now, if we think about it, intervals read from left to right on the x-axis. So all the way out to the left is -infinity. All the way out to the right is positive infinity. And we graph, people tend to typically go from left to right. So let's see where it is at -infinity. So I'm going to search these two things and look for a -infinity. And the only place I see -infinity, it's only going to occur once, is on the negative interval. That means at the far left at -infinity, it's going to start below the x-axis. So when I draw it, I'm going to start it below, but then I've got to go up. It's going to cross at the point, and when I get up to the line, I'm going to turn direction and then go back down. It's got to cross at the point, but when I get to the line, I'm going to turn direction and go back up, and then it's going to cross at the point. Now let's see what else is true. That means that at the end, at positive infinity, it's positive and going up. But look at this. At positive infinity, it's going up, just like we thought. All right, let's try another one of those. Okay, so positive and negative intervals is above and below the x-axis. So where it switches from positive to negative is where it's going to cross the x-axis. So we can find an x-intercept at -3, 0, at -2, 0, at 0, 0, at 2, 0, and at 3, 0. Remember, you can read it off positive or negative because these are the exact same numbers. Look here, -3, -2, 0, 2, and 3. You don't write the infinity down. And remember, these are not ordered pairs, they're intervals. So they're saying it's positive from this number to this number on the x-axis. So the first thing we're going to do is plot those points. So I've got -3, 0, -2, 0, 0, 0, 2, 0, and 3, 0. All right. The increasing and decreasing is telling us where it goes up and down. So when a decreasing interval starts and another one begins, it's going to switch directions. So those are our turning points. Okay. So these are the turning points. These are the x-intercepts. Okay, so my turning points, I'm going to read them in order, would be -2.67, -1, +1, and 2.5. If I read them off the other one, it'd be negative 2.67, negative 1, 1, 2.5. Same number, doesn't matter. Okay, I know it's not exact. We can figure it out. Negative 2.67 is going to be more than 2, but less than negative 3. So right in here, negative 1 is easy. Positive 1 is easy. And 2.5 is in between the 2 and the 3. Okay, so these are my turning points. So now where do we start? Well, we want to start on the left. The left is negative infinity. The right is positive infinity. So we want to figure out at negative infinity on the left, where is it? Well, negative infinity is right here, and negative infinity is in a positive interval. That means on this one, I got to start up. So when I do that, I'm going to go through the point. When I say up, I mean start above the x-axis. I'm actually moving down. And if you look at this, at negative infinity, it's decreasing. So that's exactly what should be happening. Okay, so I'm starting up, but I'm decreasing. So I'm going to go through the point, turn at the line, go back up, through the point, turn at the line, through the point, turn at the line, through the point, turn at the line, and there is my graph.